Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me RouterBob. In this video, we're going to take MDF door making to the next level, and I think you're really going to like it. In the past, our MDF door videos have been really popular, and that's whether it's wainscoting, shaker doors, MDF doors. But in those videos, we really focused on the tools. And so you take a tool set, the tools have a certain relationship to each other, and the outcome is a door that looks like a solid wood door. All right, but in this video, I wanted to take it to the next level. And it turns out CNC Shawn also has a cabinet business, and he was able to provide us a residential job. In fact, it's got 15 rooms, and we picked one of those rooms to actually run for this video. And here's what it's got. It's a dining room. It has drawer fronts. It has doors. It has glass doors, and it has decorative polishers, all that are created as part of KCD. So that's what we wanted to focus on. Now, let's look at KCD. All right, here's the job in KCD, and this room is actually a dining room. Now, let's talk a little bit about what's involved here. So these are windows, and then this is a shorter cabinet here, and what these look like, these are actually regular shaker doors or mission doors, depending on what you call them. These are drawer fronts, and these are glass doors. Now, let's actually take a look at this as the rendering. This is what the actual render job looks like, so it's really nice. Now let's look at some stuff. Of course, what we're showing in here is books. You would probably have glassware, whatever. You may have tablecloths in these drawers. So these are 6 drawer fronts. And then there's actually 4 what we would call shaker doors in the bottom. But what's neat about this is there's actually 4 glass doors. And I want to show you how you make glass doors. And then there's something else, and these are pilasters. They're decorative pilasters. They're applied to the top of the face frame, and they're actually generated in KCD. There's one thing that we thought, you know, what we really need to do is on those, we need to add scribes over here so that we can make them fit the wall. So, you know, at this point, let me show you how we alter a part in KCD to make that scribe. Now, these are the pilasters here, and only the outside ones need the scribes added. All right, so let's take a look at how you do that. How do you modify a part like that at the part level in KCD? So here's how you do. You go to Parts, you select your cut list. All right, then you want to go to Units, and you want to unselect everything. I only want the parts from this job, and I hit Calculate, and then what it's creating is it's creating DXFs. So there's a DXF for the part. Now, if I go down here a little bit, I'm looking for one that says fluted. There's one. So there's the fluted part, and you can see that's pretty much symmetrical down here. Now, let's go to View, Edit CNC Part, and I want to explain a couple things to you, because one of the things people don't understand is how does the software know what to do? Well, when you set up KCD, the CNC part, you're creating terms like operations. For instance, this is a good perimeter cut. Well, here's what that means. That means that geometry, when it's output as a DXF, is on a layer called perimeter cut. Now, we're going to look at this later. All right, it's on a layer called perimeter cut. So that means when the software starts applying toolpaths, it says, okay, anything you find on perimeter cut would be an offset, a profile cut's really what it would be, so it would go around the outside. That's how the software knows what to do now. So anything we do here gets updated, and then that shows out when we put code out. So what we want to do is select this part, and all I'm going to do is change that dimension. The Y value says 3. I'm going to change it to 3.25. I'm going to do the same thing here. Change that to 3.25. And then when I save that, that gets updated, and that will actually show up as that size part in the nest. One of the things we've never actually done on an MDF door video is show you how to make a glass door. It really involves machining on the back side. So think about the process. The nest gets cut first, so that produces the outside of the door, and then it produces a cut on the inside that's an 1/8 of an inch bit that goes probably halfway through, because that's going to get intersected. Now, then that's taken off as a secondary operation. It's positioned with part locator pins because it's already to size on the outside. And then we actually apply the tool paths for the backside operations. Now let's go to KCD and I'll show you how we do that. All right, once our design's completed, now let's look at how we nest the parts and generate machine code. So I go to Parts, I go to the cut list method, I select the units, and everything's selected by default. I only want to do the dining room. I go Calculate, and what it's doing is it's creating an electronic drawing, a DXF drawing that has information on layers for every part. Then I just simply say Nest All, and it creates a nest. All right, here's the nest. So here's the first sheet. That looks great. Here's the second sheet. And here's the final sheet. Now, here's something interesting. You notice there's a lot of area here that doesn't have any parts on. That's called a remnant, and it's always common. Anytime you do a job, the last sheet may have areas like this. But I want to show you something that's neat. If you notice, everything is referenced off this lower left-hand corner, and that's referenced off your part locator pins on the table. So I don't need a full sheet. I just need a piece that's big enough to cover that. Well, that's what we call remnants. So what I do is I keep a list of what remnant sizes I have out there. It just makes it easier. So I can tell the operator, use this remnant to cut that out. So that's how we do that. Now, let's look at how we do the backside machining. Now, when we get ready to do backside machining, we kind of have to make a decision on how we're going to hold the glass in. Now, first off, there's normally a rabbet along the back on the inside, and the glass sits on that ledge. Now, you could simply glue it in with silicone. You could make other pieces of molding, but they also make a vinyl glass retainer. It comes in rolls, and it fits in a little slot, and you can miter the corners, and it looks really, really good. So I decided, I think I want to do that. I want to incorporate that. So then the question becomes, how do you tool path it? Well, what does it require? Well, it requires a groove into the side, inside there, and it needs to be about a 1/4 inch deep, and it needs to be 1/8 of an inch, and the distance above the rabbet is the glass thickness. And I couldn't find a standard tool like that, and so I thought, well, I'll call Vortex. Vortex makes custom tools, so I talked to them about what I needed to do and what I wanted to do. I said, well, I'd like to have a 1/2 inch shaft because I think the tool will last longer, and I told them what the geometry had to be. So in a day or so, I get a drawing back and said, well, this is what we think will work, and they designed the tool for me. And I looked at it, I checked the dimensions out, and I said it's perfect. So that's where that tool came from, and you're going to see that when I start tool pathing. All right, now let's go back to our list of parts, and I'm looking for one that has glass in it. So it says glass panel. That's what this drawing is. Let's go to View, CNC. So here's what this drawing is. So it's going to be a DXF. That's the type of drawing. Okay, here's the outside, and it's on a layer called Perimeter Cut, and then there's an inside piece of geometry, and it's called Frame Clean Up Cut. Once again, layer names are what KCD uses to figure out what to do. Now, here's what those represent. This is actually the outside perimeter cut. So that geometry, when I cut that, that's the outside of the door. And then this happens to be what defines the inside, and you notice it's a centerline cut. So that the tool is going to be 1/8 of an inch in diameter. So those are the two pieces of geometry that I need. Now, let's talk about something. Let's talk about mirror parts. In this case here, we don't have to worry about a left and a right or mirror because it's symmetrical. That's not always the case. You may have stiles or rails that are different widths. You may have different kind of panels. So to do the back side, if you don't have it mirrored or an equivalent, it's probably not going to work. So basically, we don't have to worry about that. I typically would do the mirroring in Vcarve Pro. Right. But so what I've done, I'm going to take this drawing, I'm going to open it up in Vcarve Pro and show you what you have to do to get the tool path for it. All right, now we're in Vcarve Pro, and I've put a sheet in there, and it's slightly larger than what that door is going to be. For setups, I've told it that the lower left corner is the origin, and the top of the spool board is Z0. And so here's what we do. First off, I need to rotate it. It's selected, so all I have to do is rotate, put the angle in, which is 90, and then I'll close that. Now I've got to position it, so we'll go to this icon, lower left corner. I want the absolute position of that corner to be 0, 0. And there we go. All right, let's look at what else came in on this part we brought in. It brought the layer names over, and we talked a little bit earlier about layer names is how KCD figures out where to apply tools. Let's see what we got here, all right? the first two are default ones. Now here's one called perimeter cut, and you see what that does. That's the outside. Then there's actually one drill. That drill hole actually got drilled in the nest, and that's 4 knobs for the door. And then there's this last one called frame cleanup. All right. So what I want to do is actually look at that piece of geometry. Well, what does that represent? Well, it represents the center line of the 1/8" tool that was used from the other side to define that inside of what would be the panel. So that's the center line because that's an engraved tool path in KCD, all right? So I have to understand that. When I'm done, I want a rabbet that's basically 3/8 wide. All right, so how do I do that? Well, let's do this. Let's go to offset, and let me show you an easy way to do this with KCD. All right, so what do I want my rabbet? 0.375, and I need to move it over for the size of the tool or half of it, so a 1/16, 0.0625, and I hit equal and it calculates it for me. And then I hit select or offset. Now that looks good. Now here's a little problem I've got. We're going to get into in a second automated tool pathing, and automated tool pathing is based on layers. So if I have a piece of geometry or two pieces on the same layer, both get cut. So let's look at this. So if I take frame cut, both those pieces of geometry are selected. So what I want to do is I want to delete the original one. One of the features Vcarve Pro has that's really useful for this is the ability to save toolpath sets as a template. So what I'm going to do is I'm going to load the template that I'm using. It's called Shaker Glass Toolpath, and they're the toolpaths. So here's one that cuts the inside profile. Okay, here's one that cuts the offset, and here what these are an 1¼ tools. And in order to get that slotting tool in there, I have to have some space. So that's what those two toolpaths do. All right, and then I've got the inside profile, which gives me square corners on the rabbets, and then this is the tool that does the glass profile. Now, so what do I do? Well, I click, let's see, let's just open this up, and we'll click it, and we'll go calculate, and that gives me that first tool path, and we'll put this out, and we'll, okay, so there's the first cut, all right, and then we come over here, let's do the second one. So that basically cut the first cut, and then we're going. All this one does is it's going to be the same piece of geometry that creates a second one. So when we run that makes it wider, and that gives us enough room to drop that tool in. Okay, then we use the 1/8" tool. We'll open that, make sure the correct tool path's applied, perfect. All right, and we'll cut that. All right, you can't really see it. Now what it did is it squared these corners out. And then the final glass profile is this one. All right, now Vcarve Pro doesn't have the ability to show a slot. So think about when you tool path it, it's the same geometry as you would have with an 1¼ straight tool. You just got to make sure you got a lead in and lead out correct. And so we'll calculate that. Once again, make sure it should be the same geometry. And we'll calculate it, and we'll simulate that. Now, what's important about that, what you're seeing here is you're seeing where the bottom of that slot is, so that's correct. Like I say, this is a problem you have in Vcarve Pro. Okay, so now let me show you something else. Let's get rid of all this. So let's do this again. So we'll get rid of that, and we'll get rid of that one, and we'll get rid of that one. Now, before I get rid of the last one, I'm going to show you a concept. So if I open this up, and you'll see this, it's available in Vcarve Pro. So when you come down here, there's a button down here that says Selector, and here's what it brings up. All right. Now, the whole point here is I want it to automatically select the tool paths based on layer name. So here's what I can say. I want you to use closed vectors. All right, and I want you to apply this toolpath to anything on that layer. So that layer is what determines what gets applied, and then down here, associate with toolpath. Now here's what that does. So let's just get rid of this. All right, so now I've got my part in here. All right, well, what do? I get the part, I get it positioned, I hit load toolpath. All right, there's my toolpath template. And all I have to do is hit recalculate, which should be that little calculator, and there's all your toolpaths automatically. And if we look at 3D and simulation, should be the same. So we'll reset simulation, and we'll preview all toolpaths. So just by having it automated, all I have to do is load the template, recalculate, and it toolpaths it automatically. That's all that's required. That's all it takes to do backside machining. So think about what's happening. We've got the part on a sheet. All right, so all the operations get cut out on the sheet itself. So what happens on our glass door? Well, a couple things happen. We drill a hole. That's what happens there. Let's go to 3D here, and you can see it. All right, so the first thing that happens is I drill a hole, and actually all the holes in the nest get drilled. Then the inside profiles and all the doors get cut. And then finally, the outside gets cut. So if we get rid of the scrap, this is what we have left. So that panel then goes to the machine and gets turned over, placed against the part locator pins for the secondary operations. What's neat about Vcarve Pro is I can copy geometry from one side of the sheet to the next. So what I've done here is I actually copied that center cut and then moved it out, offset it, and got rid of the one I copied. And so that becomes our tool path for the backside. So now that we've got that figured out, let's go up here to 3D view. First off, let's switch back to the front side, all right? Let's go to 3D view, and then let's tell it to preview all sides. So here's what's gonna happen. So there's what happens in the nest. And then it gets flipped over, and there's the backside machining. And when everything's done, we should be able to get rid of the scrap. And there's our door. So that's how you make a glass door. The tool pathing is done. We verified everything with simulation. Now, we've done the nest and we've generated the codes for the nest, and we've also done all the backside machining and generated the G codes for that. Now we'll send those files out to CNC Shawn and we'll actually run them.
All right, I just got the files from Bob. We've got 3 files from KCD and 1 from Vcarve. I've got the machine loaded up, but before we start it, let's talk about our tools. We've got a 5mm brad bit for drilling the knob holes. We've got an 1¼ Vortex shaker door bit for hogging out all that flat panel work. We're gonna run an 1/8" 2-flute down shear to clean up all the corners on the doors and for the glass doors. What's next? We've got a 2-flute down cut ball nose for the pilasters to get that fluting tool path. And then we've got the 3-flute mortise compression bit. It's a 3/8 bit we're gonna use for cutting everything out. Provides a great clean finish. And then the last one on the reverse operation, we've got Vortex's custom tool they made to do the slot cutting for the glass retainer. Now, all that we got left to do, get these parts cut out. Let's get started.
Hey, Shawn, how did the project come out?
Hey, RouterBob. These doors turned out perfect. You know, one of the many reasons I love the ShopSabre machine, the technology they bring forth with the ball screw. Look how smooth that is.
Wow.
You're not catching anywhere.
Wow.
The edge finish is just perfect.
Perfect. Hey, I'm curious, what about the pilasters I added the scribe to? Can you show me that?
Yeah, they turned out great. We've got one right here. This one's got the scribe. You can see the fluting turned out perfect.
Wow, that's nice. Now, what about the backside machining on the glass doors? That's something we normally don't do. How'd that
Right,
come out?
the glass doors were a lot of fun. Like you said, we don't do a lot of backside machining, but they turned out perfect.
How did the Vortex tooling work?
That custom tool from Vortex worked perfect. You can see the slot is perfectly cut all the way around. The entry exits were perfect. The fit is perfect for this glass retainer. Snugs right in there. It's going to hold that glass perfect. There won't be any rattle. The customer's going to
That's great.
Gonna
That's
love
great. Okay, Shawn, what's next on this project?
So next we're going to load these up. We're going to bring them back to the shop, get them all prepped for paint. They'll go off to the job, get installed. And after everything's done, we're going to be able to get some pictures taken. And please come check us out on Facebook or Instagram. You can see how the project finished up.
Well, I hope you enjoyed the video. If you'd like to see more videos like this, be sure and subscribe to our YouTube channel. If you need more information, you can contact us at shopsabre.com. Thank you for watching.